All right, we can go ahead and get started. Good morning, everyone, and welcome to the Members' Day. So, like Martin, I've also kept this pretty open-ended and for discussion today. I'll start with just giving people a brief introduction to this task group that's been running for about formally about 3.5 months or so. We'd been working on this one before that as the group was being formed, so we made some good progress in the last quarter or so. So before I start, I don't want to spend too much time on the background. People are familiar with it. Can I get a quick show of hands? Like, are people generally familiar and have been following this task group, or are people coming in completely cold? Yeah, like people who are familiar with the work, I guess. Okay, right, at least more than half, so that's good. So that part will be boring for people because they've seen it probably tens of times. And then Gurney Hunt is my co-conspirator in this task group from IBM. So I'll cover the status and sort of next steps and keep it open for discussion. So this is just a quick snapshot of the current charter, right? What this group is chartered to do is work on a architecture that can be used for application class processors, RISC-V processors that are targeted to address the requirements, specifically the security requirements for confidential compute, right? Now, confidential compute, for folks who are familiar with the topic, is a pretty broad security topic, right? It touches a lot of things on the system in order to achieve its goals, right? Which is basically to provide a more enhanced model of security for data that's being processed on an application processor. And obviously the data has to then be tracked as it's being processed on the RISC-V based processors, but also on other subsystems of the platform, right? So the way we sort of propose this task group and the way we've been going down this, doing this work is in these three areas that you see here. The first and the foremost goal we said was to look at this reference architecture, discuss this in the task group, and understand what's going to be the impact on the software interfaces. Because what we're really doing here, or what most confidential compute architectures do, are they define your trusted compute base, right? And one of our other functional goals, non-security goals, was to make sure that we can bring in a lot of the software workloads that are also progressing in parallel, right, as we are defining new ISA for user mode, for privilege mode, etc. And we make sure that we reduce the amount of friction to bring software into this trusted execution modes, right? And so from an application processor perspective, we chose to build on top of the hypervisor extension in RISC-V as one of the baselines for confidential compute. And again, this is not different from a lot of the other architectures that have also used that same abstraction of hardware virtualization to extend that for confidential compute. Obviously, just the ISA parts are not enough. So we started with the focus on the non-normative security recommendations, looking at the reference architecture. The two main normative parts that we want to work on, that we've been working on in this TG, is the first one is the non-ISA or the software ABIs that we need between the TCB and the non-TCB elements, right? So in this figure, you see that in two forms basically. One at the host level, right, which is basically between your privileged software, existing privileged software operating systems, VMMs of the platforms, interfacing with the TCB elements that we introduce on the platform, in this case called the TE security monitor. And also interfaces between the workload or the guests on the platform, which are shown here as the TE VMs, and the security monitor or the host. And so effectively the TE security monitor is partitioning the responsibilities on the platform and taking on some of the security enforcement properties, right, while keeping most of the resource management, scheduling, those kinds of functionality within the host OS or the VMM. And that gives us sort of a model that we can work with to essentially make sure we don't negatively affect the deployed ecosystem or the deployed functionality that's out there in Linux, KVM, and other kernels, and can also easily bring in some of the existing workloads, be it be VMs or containers or processes, right? And it gives us the right software abstraction. So that's where we chose to start working on. And that's most of the progress we've done in the last 3 months or so. The other pieces are also important. One is recognizing what aspects do we need in extensions in the privilege ISA. So far we've been building on top of the hypervisor extension as it's defined, and we've identified a couple of areas where we might need platform support or ISA support. The first one is, how do we recognize confidential memory? And this might effectively become, some notion of think of an extension of a physical memory attribute to specify that certain memory regions are confidential. And that could be then mapped to different platform attributes, depending on the threat models you're trying to address. The other couple things are securing interrupts, right? We want to make sure here when TVMs are running that those contexts are protected against attacks from the host in terms of injecting spurious exceptions or spurious interrupts, things like that. So it sort of speaks to the, how do you ensure the runtime integrity of those workloads that are running as confidential workloads. And then the third one is extensions on the IMMU and things like that. And that's really, again, sort of completing this functionality so that when we go down the path of assigning devices directly to VMs and things like that, we can also bring that same functionality to confidential VM workloads as well, right? So these have been sort of our 3 work areas, right? And so this is just a quick snapshot of where we are at right now. What we've been doing in the task group is going through these different aspects of the system functionality that we need to address. Starting with the most important aspect of how do we isolate and create the notion of confidential memory? How do we manage that confidential memory? What kind of attestation interfaces do we need? That's another key sort of a cornerstone aspect of confidential compute is how do you support hardware-based attestation, right? The fact that you can prove to a relying party, right, that the workload that they're relying on that platform is actually running with some hardware-rooted trust, right? That's sort of the second interfaces. The third and the fourth I mentioned earlier, this is about how do you ensure the CPU state is isolated, and here we have to take into account the fact that different configurations of the platform might turn on different ISA features, right? Secure interrupt management I spoke about. We have to think forward about what would be the direct IO assignment model, and start thinking about sort of what would be the other platforms mechanisms we need to rely on in order to protect that, and what impact that has on the software ABIs. And then a bunch of other SOC and platform considerations around, how do you trust the performance monitoring subsystem? How do you authorize the debug correctly so that you know that you can still debug a platform but not divulge any of the secrets inadvertently, right? So we are at the point right now where I'm glad that we have had enough discussion on these areas where we can start looking at the draft specification that the group has pushed out to the GitHub, and we can start pushing putting issues and PRs against the draft specification. So I'd encourage all of you, if you haven't already, to go look at the draft specification and the ABIs that are proposed for these sections above, and start putting your comments and feedback there, right, as we go into that process. There are a set of items we still need to discuss in the work group, and I've called those out as open areas, right? One is, what recommendations do we want to make on side channel mitigations? How do we approach some of the other software functionality that we will need to address, like, and I've just put some examples here, and I'm sure there are others, like how do we address live migration for these confidential workloads? How do we do, what is the kind of interfaces do we want for securing the TCB updates, right? Because again, that's an important aspect of the attestation properties. You want to be able to have a platform that supports confidential compute, that if you recognize that there is a issue in the TCB firmware or in the TSM, for example, you are in a position to revoke the certificates and be able to recover the TCB back to a usable state, right? And those require the additional sort of interfaces on the platform. So this is again just to give you a quick snapshot of like what what areas those software ABIs live in right now, right? So these are the different lives. We've been looking at it sort of a life cycle of a confidential workload on a platform, and mapping those to the different aspects of, hey, how do you enumerate the capabilities on the platform? How do you actually instantiate a confidential workload? How do you need to interact with the memory access control properties or the memory encryption properties you have on the platform? When a TVM is executing, what's the impact on the interfaces that the host uses to actually make a vCPU runnable on the platform, right? What are the context switch paths that we need there? How is the context switch path secured for between TCP and non-TCP elements, and so on, right? All the way, to the end of the life cycle of a workload, where when a workload ends or is terminated, how do you reclaim the resources so that you can either reassign confidential memory to other workloads or reclaim it back for non-confidential workloads, right? So this is sort of a quick snapshot where in the technical steering committees, when we initially reviewed the charter, this was sort of the list of items that we said we wanted to work on, and this is currently sort of where we are at, right? As I said, the initial snapshot of the TSM host ABI and the TSM guest ABI are now sort of specified in a draft specification that you should be able to find on GitHub. We have an early implementation, or a first sort of open source implementation of a TSM that works on a a QEMU-based H extension implementation that people can start playing with. This is sort of meant to be like a first implementation that people can look at the ABIs, can start interfacing with it, and as we create the right other modules that are needed here, like interfaces with Linux KVM, interfaces with OpenSBI, people can start actually playing with it and getting experience with the ABI, right? So this is sort of like the host software and the CPU side of things from the interfaces and the POC perspective. But there are a bunch of other things that we need to capture as well, right? So we had called these out in the TG charter discussions, and these will end up being more recommendations, right? For example, the top two ones might end up being things that we work on with the privilege ISA TG and figure out how do we specify the apt mode qualifiers that we need over and above the H extension. How do we specify the properties that we need for tracking confidential memory on a platform, right, by virtue of this confidential PMA? What are the IMME extensions that we need? We've talked about some of those in the task groups, but we need to sort of take the next step and talk about more detailed description of those. The ones that are in the second set are more platform recommendations, right? So from a practitioner's perspective, if somebody is building a platform that implements confidential compute using and supports the apt ABIs, they have to think about a bunch of other things that impact the security of that implementation, right? So this is all the way from what kind of properties are existing in the caches at different levels on the system, right? From TLBs to page table caches to other I-side, D-side caches and combined caches. The hardware root of trust has some important recommendations in play here, right? Because we want to ensure that we have a TCB that we can report, independent from other TCB elements that may be reporting on the platform, and it's updatable, etc. Other interactions, we've been talking a lot to the SOC infrastructure HC on, how does this interact with QoS features, right? How does this interact with RAS features? As well as I spoke a little bit about debug and perfmon. And then some of the things like devices, we would probably, look at as part of a follow-on work where we look at what are the device-specific features or capabilities that are needed to support interaction of a device with a TE, right? And we've started talking about some of those in terms of the direct assignment ABIs that we should document and understand, right? Because there is some interaction there with other aspects of the ecosystem, like what fabric is the device connected to, through, like is it PCIe or is it CXL? And some of these discussions are also happening in those forums. to understand, what kind of support they need in the fabric to be able to support confidential compute. And then the security analysis line that you see at the bottom is sort of a place where we said we want to capture some of these best practices and recommendations, right? Like if you're using certain crypto modes, what are the recommended crypto modes to use? What attestation protocols should we be standardizing on, right? That sort of work well with other confidential compute architectures, so that if people are placing a confidential workload on one architecture or the other, at least from a relying party perspective, there are some common standards that we can use. And a lot of that work is sort of happening in the ITF as part of the RATS working group, so that there are some, existing protocols and things like that people are discussing. And we've seen that also in the confidential computing consortium. All right, so I'll pause there. Hopefully that gives you a pretty good snapshot of where we are at. There are some discussions that are ongoing or needed, right, that are in progress. And I'll call out some of these. There is an interaction with M-mode isolation, or what we used to call lightweight T in the work group. And there's been some discussion there on, like, what's the right architecture do we want to recommend, and what support do we need in the ISA for really tightening up the TCP components that run in M mode, right? So in the apt architecture, we have a TSM driver that runs in the M mode, right? One way we could sort of harden that architecture is by deprivileging other components out into U mode, or we could build some ISA support to isolate components within M mode, right? So there are a couple of those discussions that are ongoing. We need to have some more discussions on interactions with secure boot, right? So from a platform integrity perspective, we might have secure boot being implemented by the platform, but the trusted execution environment sort of need their own, transitive trust chain, right? That is independent from the platform boot trust chain. So that, but a lot of the APIs and ABIs there are probably common that we can reuse. And as I mentioned, some of the other areas that are listed here, we have to start discussing. We haven't really discussed those much in the work group yet, right? But those are also important ones. And there are probably others there that I haven't listed there that people can think of. All right, so let me just pause there and take questions, comments, feedback. Any thoughts on sort of how the task group is going? Any comments, feedback is welcome. I mean, yeah. Yes. That's correct. Yeah. So there is a security model task group that was started about 6 to 8 months back. We did some early work. The goal of that security model task group was to essentially write down these sort of security recommendations. What are the different elements of security that somebody an implementer needs to consider when they're building a RISC-V based platform. For example, what are the properties that you would need for a root of trust? What are the mitigations, hardware mitigations you should put in place for specific security issues? So as part of APT, when we started talking about, well, how do we capture these best practices or recommendations, we said, hey, the best place to probably put something like that is in that security model document. And for that, there is a TG that was formed. And I think we have a vice chair, but we don't have a chair.
Yeah, unfortunately, the chair changed roles in this company, so he had to resign. We're about to announce the new chair of the security model. That will be hopefully this week. Ravi and I have discussed it. And then that work will start again in earnest. One of the first things we discussed last week in the Security Horizontal Committee was to try and draw the bigger picture for each of the various use cases and operating modes of trusted execution, both in the lightweight microcontroller space right up to confidential compute in the server class. So we don't have some of the use cases and big picture structures, and the obvious place to put that is also in the security model, and then to link that into the threat model and describe how we mitigate the higher level all of that work's going to start gaining awareness to the security level and hopefully in coming weeks.
Yep. Yeah, and I had sort of just jotted down some call to action points here. I already called out the first one, which was, please go look at the draft ABIs that are proposed in the specification. There's a convenient PDF version if you want to read that, or you can read the ASCII doc version, which is better for proposing changes, etc. There are a couple of joint sort of POC efforts going on, right? One, we have an initial TSM implementation that is great for people to start looking at and experimenting with the ABIs. That's sort of a baseline we want to build on to get sort of some of the, as we ratify some of the ABIs. And then we have been talking to the hypervisor SIG folks to also figure out what's the right changes we need for KVM and other implementations so that we can do the host side POC as well, right? So we can sort of show the functionality working on top of QEMU and things like that, right? Until we get hardware implementations of the hypervisor extension. And there's some sort of common tests, etc., that we should be thinking about as we evaluate compatibility, right? Because obviously KVM and Linux have some of these paths coded for other architectures, right? For Intel TDX or for AMD SEV, SNP, and ARM CCA. And we are sort of proposing an analog, right? There are obviously architectural differences, but that at the abstract ABI level, I think we can interface with a lot of the KVM flows that exist. But we need some RISC-V support in the KVM unit tests, etc. That would help to sort of accelerate that compatibility testing. And there's a slide pointer to the last Linux Plumbers discussion where we called out here's the actual touch points in KVM flows, right, for different TVM management that we would touch, right, we would modify just to get the feedback from the Linux KVM folks. So there's a good discussion there as well. Any other questions? Andy, did you have anything else from the security HC side you want to? Yeah. All right. Yeah, and if folks want to hear more about some of the intricacies of the ABI, the threat model, I think we have a technical talk on Wednesday afternoon. So folks are welcome to join, and I'll go into a lot more gory details about the threat model and how to think about the aspects of the root of trust we rely on, and how do we build the trust chain and some of the details of the life cycle of the ABI. Since we have a little bit more time there.